go over a few things with gas laws. Gas laws are relationships. They're relationships among pressure, volume, temperature, number of moles. Hold on R, okay? Scientists, Boyle, Charles, Gay-Lussac, these were scientists who first made mathematical relationships. They're actually math models describing what the relationship is among pressure, volume, temperature, also number of moles. That's Avogadro. I don't have him up here. Usually don't use that with combined. Now, two of these, Charles and Gay-Lussac, were hot air balloon enthusiasts, basically athletes. They were trying to get a competitive edge for hot air ballooning, which is a huge craze at the time. But these scientists came up with different laws, okay, about relationships. So P is pressure, V is volume, T is temperature, N is number of moles, R is called the gas constant. And if you have it in atmospheres, liters, moles, Kelvin, that value is 0.082. It's different if you had this in PSI, liters, moles, Kelvin. It's also different if you have it in kPa's, liters, moles, Kelvin, okay? But we're gonna use 1R, so when we do pressure, we're gonna do atmospheres, okay? Another thing you may see is called STP, Standard Temperature and Pressure. That's 0 Celsius in 1 atmosphere. Now, what are Boyles Law? Boyles Law is about the relationship between pressure and volume as it changes. Charles is about volume and temperature as it changes. Gay-Lussac is pressure and temperature as it changes. What's the result? Again, whether they're direct or indirect, these equations each describe these relationships. Now here's what's nice. Remember, we have no imagination in science. We can take these relationships, put them in one called the combined gas law. P1 V1 over T1 equals P2 V2 T2. And we can summarize in one equation the relationships among pressure, volume, temperature as they change. In other words, if we want to know the result or the resulting pressure, as long as we know the other information, we can determine it. That's what the gas law is, nothing more than a mathematical relationship. Now, there's one more immediate gas law, and that's Dalton's Law of Partial Pressures. We're not going to do problems, but I want to mention it. What it says is the total pressure of the gases in a confined space, a container, a tank, etc., is the sum of the partial pressures. For example, if you have air confined in a gas cylinder, okay, the total pressure of those gases in the cylinder is the sum of the partial pressures of nitrogen in the air, oxygen in the air, carbon dioxide in the air, water vapor in the air, etc. That's all that is. In order to determine the total pressure, we add up the partial pressures of the gases in a mixture in a confined space like a gas cylinder.